In our previous lesson, we implemented support for role-based authorization in our REST API. We used the features we had available in ASP.NET Core Identity to introduce the concept of roles, connect them to our users, and then encode them inside of the JSON Web Token to implement role-based authorization inside of our REST API. And this authorization mechanism might be all you need for the majority of use cases, but there are some situations where you need more granular and more robust access control, and this is something I want to discuss as part of this lesson. I want to introduce you to two additional authorization mechanisms, role-based access control and attribute-based access control, and discuss how to implement them and what are the pros and cons of each approach. Let's start with role-based access control. How this works is by introducing the concept of a permission and connecting our roles to the permissions. So we're mapping the permissions to the roles, and then we are assigning roles to our application's users. The benefits of this approach is that it's relatively simple to manage, it scales well, and it's easy to audit our authorization policies. However, even though it's a very granular authorization approach, it has limited flexibility in how much authorization it can offer and what we can achieve using permission. There's also a possibility that we get role explosion and permission explosion in very complex systems, and the obvious downside is it can handle context-based decisions, which is something that attribute-based access control solves. Here's a simplified diagram of what our system will look like with role-based access control. We will have our application user, and the user can belong to one or more roles. Each of our roles will have a set of permissions assigned to them, and this in turn determines what the user is allowed to do. If we circle back to our application for a moment, with simple role-based authorization, we use roles to define an authorization policy for our controller. Anyone who is assigned to this role is allowed to access the endpoints on this controller. With role-based access control, instead of having role, we would have permissions. And you could specify these permissions on the level of an individual endpoint. And for example, we could have a user's read permission, and this would allow a user that has this permission to access this endpoint. Similarly, you can define a user's modify permission or a user's write permission, which will allow you to access the post or put endpoint and perform the respective operation. So you can see how using permissions gives you more granular access control. When it comes to how you can implement this, you might even be able to make this work with ASP.NET Core Identity. There is a concept of role claims which you can use to represent permissions on your roles, and then generating a JSON Web Token would involve finding all of the roles of a user, then finding the respective claims for each of the roles, and then encoding those claims as permissions into the JSON Web Token. And then we can use these permissions to define access policies on our application's endpoints. Attribute-based access control uses the attributes of the users, resources, actions, and the environment to make access decisions. The benefits of this approach is that it's highly flexible. You can use it to define very complex authorization rules, and this in turn lets you simplify your policies compared to some other authorization approaches. Unfortunately, it comes with a few drawbacks. It's very complex to implement compared to role-based authorization or even role-based access control, and there is a potential performance overhead when evaluating complex access policies. With attribute-based access control, we define an access policy which may include the user's attributes, the resource attributes, the environment attributes, the current action attributes, and all of this comprises an access policy. We need an additional component that represents a decision engine that evaluates this policy and produces an access control decision. This should simply state whether the current user is allowed to do something or not. To give you a more illustrative example, let's compare two access policies that we could define with role-based access control or attribute-based access control. With role-based access control, we can define a policy that says all managers can view financial reports. This could be a permission assigned to all users in our system who are assigned to the manager's role. On the other hand, with attribute-based access control, we can define an access policy that says users can view financial reports if they are in the finance department, during business hours, and from company IP addresses. So you can see how this type of authorization policy is much more complex, and it consists of multiple factors that come together to define the authorization rule. In the .NET ecosystem, there are a couple of popular solutions for implementing attribute-based access control. One of them is Caspin, and I'm going to leave some additional resources right under this video if you want to learn more. And I want to wrap this up by saying that the number of systems that really needs attribute-based access control is somewhat limited. implemented. A good example of this could be something like Google Drive, where you can define various authorization policies for the documents that you share with other users. For example, you can have an access policy for documents in a particular folder. You could also configure who in the organization is allowed to access which folders or which documents. So if your system really needs something like that, then you should consider attribute-based access control. So this was a quick overview of some advanced access control policies that you might consider for your applications. Be sure to weigh the pros and cons of each approach and carefully consider if your application really needs this type of access control. I think we can end our discussion about authorization here and move on to our next lesson, where we will be talking about integrating with external APIs. In all of our lessons so far that were part of this chapter, we were talking about authentication and authorization. However, we were always discussing this from the perspective of our REST API. The clients that want to use our API have to properly authenticate in order to be able to access the resources that we are exposing on our REST API. However, in this lesson, we will change things up a little. We will become the client and we will integrate with an external REST API. And we are going to integrate with the GitHub REST API, which also has excellent documentation that I highly recommend that you check out. I will leave the link to the documentation page right under this video if you want to explore more. As part of this lesson, I will walk you through just the things that we need in order to integrate with a couple of API endpoints. When it comes to authenticating with the GitHub API, it uses a bearer token that you provide as part of the authorization header, and assuming that the token is valid, we will get access to protected endpoints, and some endpoints even return additional information when you are authenticated. The approach we will be using is authenticating with a personal access token that you can obtain if you have a GitHub account. And this will allow us to introduce some interesting features into our DevHabit application. Another thing we have to think about when integrating with external REST APIs is rate limiting, and in case of the GitHub API, there is a fairly generous rate limit if you are authenticated, which comes out to about 5,000 requests per hour. Rate limiting is also a topic when it comes to implementing our REST API, and I'm going to discuss this more in the advanced concerns section. Now let's see which API endpoints on the GitHub REST API we will be calling. The first API endpoint on the GitHub REST API that we will be calling is the endpoint for getting the authenticated user. The route is just /user, and of course the base address for this request is https://api.github.com. We need to provide a valid bearer token, and you can see that the GitHub API uses a custom media type, application VND GitHub plus JSON, as the value in the request header. We can also comment on the documentation for this API endpoint. For example, you can see it contains the HTTP status codes that you can expect, like 200 OK, 304 not modified, and then we have two status codes if we aren't authenticated or we don't have the required level of permissions to get back a response. The documentation also contains an example response, which you can examine to see what you can expect to get back from the REST API. And what's interesting to note here is that the GitHub API uses hypermedia. They don't have a collection of links like we implemented it. However, they do have many properties that represent URLs to additional resources. For example, the received events URL, the events URL, the URL where you can access the user's repositories, and you can see how they follow a different URI from the specific endpoint that we are calling. Octocat, in this example, is the username of the current user, and this is something that is constructed on the backend, the GitHub REST API, before it's returned to us as the clients. And I can definitely say that the GitHub API is one of the most REST compliant APIs that I've seen out there. The second API endpoint that I want to integrate with is the endpoint for listing the events for the authenticated user. Here is the URI where we will send a request, its users, then the user's username, and then events. And this is used to return the latest events for the current user, which we are going to use inside of the DevHabit application to implement habit tracking. I will talk more about this in some of our upcoming lessons. This endpoint supports pagination, and the maximum page size is 100, while the default value is 30. And if we take a look at the example response, you can see that it's returning a top-level collection, which isn't something that I recommended inside of this course, but nonetheless, it's something that you have the freedom to do as an API designer. Now let's jump into our code base and see how we are going to integrate with the GitHub REST API. In order to save us some time, because this integration isn't really simple, I went ahead and made some updates to the code base behind behind the scenes. I recommend that you download the latest version of the source code that will be available right under this video, and I will walk you through the changes that were made behind the scenes. I will start from the entities folder, where we have a new class, the GitHub Access Token. This is a simple type which I will use to store the personal access token for the current user. We have to associate this with the respective user, so there's a user ID as the foreign key, and I'm also tracking when this personal access token expires so that we are aware that we should notify the user of the expiration and they can update the access token. There is a respective configuration type for this new entity. In the database configurations folder, you will find the GitHub Access Token configuration. There's nothing too interesting here except the fact that I'm defining a unique index on the user ID column, and this is because I want to prevent users from having multiple access tokens in the database. You can only have one valid access token at a given time, and whenever you try to persist a new one, it will override any existing one. So this is how our entity is set up. Now I also added some types in the services folder. And let's start with the GitHub Access Token service. This is just a simple wrapper allowing us to persist, get, and revoke the access tokens for the user. Let me walk you through the methods that I've implemented inside. We have the store async method, which is going to accept a user identifier, a DTO object, which encapsulates the access token that we are trying to store, and we first check if there is an existing access token for this user. If there is, then we're going to override the token value and update the expiration time. Otherwise, we have to create a new access token and then we persist this using EF-Core. In the getAsync method, we're just returning the token value, and we will use this when making API calls to the GitHub REST API. And then there is the revoke async method, which allows me to revoke an access token from our system by deleting it from the database. Now, when it comes to calling the REST API, there is the GitHub service, which is another new type, and this is where I will call the GitHub REST API using an HTTP client. I'm using the HTTP client factory to construct my client instances, and I'm creating a short-lived HTTP client for each API call. Here's the method for fetching the user's profile, and the URI for this endpoint is just user. I'm configuring the base address when setting up my HTTP client, which I will show you in just a moment. So all we do is just send a GET request to this URI, check if this is a success status code, and if it is, we're going to try to deserialize this into a GitHub user profile DTO. The second method here calls the events URI for the current user, and here we have to pass in the username of the current user together with the access token, where the access token is used to construct the HTTP client and the username is used to create the URI. And I'm setting the per page value of 100, which is the maximum value. If we get a successful response back, I'm deserializing this into a list of GitHub event DTOs. Here's what it looks like to create the HTTP client. I'm calling the create client method on the HTTP client factory, which allows me to resolve a named client that I can configure with dependency injection. And I just want to set my access token as the bearer token value in the authorization header when we are sending requests to the GitHub API. Lastly, let me show you how these are configured with dependency injection. In the add application services method, you will see a few additional lines of code, registering the GitHub access token service as scoped, registering the GitHub service as transient, and then we are configuring our named client with the name of GitHub. And here I'm setting the base address. In this case, I'm hard-coding this value in the code, but I could also retrieve it from my application settings. And I'm setting some default request headers. These are the user agent header, where I'm setting the value to devhabit version 1.0, and then the accept header, where I'm specifying GitHub's vendor media type, which is vnd.github plus JSON. Of course, the respective database migration is also created, and it will be applied when the application starts. So what is left for us to do as part of this lesson? Well, we have to expose a set of API endpoints on our REST API to allow us to integrate with